Well, I'm glad you came on here to get up to date with the part 2, 3s, and 4s of your review packet. We're going to look at the first one. Number 26 wants to know whether this is a function. 27 is the same question. And justify your answer either way. So when I'm looking at this, I'm going to look at the x values. X is 1, x is 3, and x is 7. Every input is unique, and it has a unique output. So this is a function. You could also make a sketch. 1, 5, 3, -1, 7, 9, and it passes the vertical line test. Number 27, you'll notice, has 3, 3, and 3, and those are the same input values. So those input values are the same, but they have different output values. That's not a function. And if you made a sketch, you would have 3, 1, 3, 5, 3, 8. You get this stacking that fails the vertical line test. Number 28, determine if the point 4, 4 is in the solution set of y is greater than -1/2 x plus 5, and y is less than or equal to 3x minus 2, and justify your answer. If you want to check to see if that point is in that solution set, then that means that that point has to satisfy both inequalities. That's an x and y value. So I could substitute in 4 for y and 4 for x and see if it's true. So now -1/2 times 4 would be -2, plus 5 would be 3. Is 4 greater than 3? Yes. And then we check the second one. It's got to satisfy both of them. Is 4 less than or equal to 3 times 4 minus 2? 3 times 4 is 12. 12 minus 2 is 10. 4 is less than or equal to 10. So yes, this is a member of the solution set. Number 29, this is a really important equation that you have to remember. Y equals a times 1 plus or minus r to the t power. That's your exponential growth and decay formula. You have to know that it's not given to you on the exam. Deposit $750. So you're going to plug this information in. Y equals 750 times 1. We do plus because it's growing. 0.07. We have to change 7% to a decimal. And to the t power. That's the first section. The second section wants you to take that same formula and plug in 18 for your exponent because it's after 18 years. I'll let you guys do that part on your own with your calculators. Okay, number 30, we're graphing an absolute value function. I'm showing you pictures over on the right of what that should look like in your graphing calculator. On the top is the table, and on the bottom is what it would look like on your screen. So all you need to do is know where to put in the ABS for the absolute value bars and put in that exact function, grab your table, and plot those points. And you should get this picture here. Make sure you plot the points exactly onto the graph. The range down below is talking about the y values. So you notice the smallest y value is 0, and it goes up from there, so to infinity. The domain are your x values. So that's on this axis here, and that's coming from -infinity and going to positive infinity. It's all real numbers. There's no restriction on the domain. 31. A local business was looking to hire a landscaper to work on their property. They narrowed their choices to 2 companies. Flourish Landscaping Company charges a flat rate of $120 per hour. Green Thumb Landscapers charge $70 per hour plus $1,600 equipment fee. Write a system of equations representing how much each company charges. System means 2 equations. So we're going to have one equation for the first one, the first landscape company, which is going to be Flourish. Sorry about my bad handwriting. And that is going to be your total fee is equal to $120 per hour. So we'll let x equal hours. And y is our total cost. So 120 times x. And then Green Thumb, their total cost is only $70 an hour. 70x but they charge $1,600 equipment fee. So there's your two equations for your system right here. And it wants you to determine and state the number of hours that must be worked for the cost of each company to be the same. You don't have to use the graph. You can if you want. You can graph them. Just make sure that you get an appropriate scale unit so that you can get 1,600 for a y-intercept. But you don't have to. You could use what I would suggest is the substitution method. You know that y equals 120x, so substitute it in. 120x, that's 1, is equal, that's when they're the same, 70x plus 1,600. And solve. 70x, subtract 70x from both sides. 40x equals 1,600. Divide by 40. And x equals 40 hours. At 40 hours, it doesn't matter which company you choose. But after 40 hours, company Flourish is going to charge more per hour than the Green Thumb company. So if you're going to only do 35 hours, I would go with company Flourish. But more than 40 hours, you would go with Green Thumb. And then the last one, Samantha brought 8 goldfish home and charted their population growth as shown in the table below. Create a function, explicit formula, g of n, to model the growth of the goldfish. Now remember, the equations that you're given on your reference sheet on your exam are going to be, for your explicit formula, a sub n equals a sub 1 plus d times n minus 1, if it's an arithmetic sequence, a plus or minus pattern, or a sub n equals a sub 1 times r to the n minus 1 power, if it's a geometric sequence, a multiplying pattern. In this case, when we look at the pattern, it is a plus 8 pattern. So we would go with our arithmetic sequence. Now this is a sub 1, that's the first term in the sequence, and so here the first term is 16 plus the pattern 8 times n minus 1. If you started at a sub 0, you would have said 8 plus 8n, and then you would have 8 plus 8n. You wouldn't have the n minus 1 because you started at a sub 0. How many goldfish will there be 1 year after she originally bought them? In this case, we would have to substitute in for 1 year. But notice that your term is in months. So how many months are in a year? That would be 12. So you would substitute in 12. And I'll let you take it from there with your calculator. Down below, part C, Sam's brother bought 6 miniature tree frogs at the same time that she got her goldfish. The frog population doubles each month. Create a function to model this growth. Doubling is a multiplying pattern. So that means for this one, f of n, the first term in the sequence is going to be 6. That's what he started with. Doubling means you're multiplying it by 2 times n minus 1. How many months will have passed when the population of frogs and goldfish are the same? So that's when, again, they're going to be equal. I'm going to do this work up here. You're going to want to graph these two functions, your 16 plus 8 times n minus 1, and see when that is equal to 6 times 2 to the n minus 1 power. So that's what you're going to need to do is graph them. Graph this line, graph this exponential function, and look for where they intersect.